FC is an latex function, then this will be equal to this. Okay, the derivative will be equal to this. Yes, FC is equal to R plus iota I, both are function of alpha. So FC magnitude will be equal to R square plus iota square 1 by 2, because square of the magnitude is equal to R square and I square. I have already explained in the I have already proved in the previous partial FC partial alpha. Yes, this will be equal to, power will be shift 1 over 2. Yes, R square plus I square power 1 by 2. When minus 1, that will be equal to minus 1 by 2, and that will be shifted as a nominator. When we take the derivative of this, this will be a 2R partial R over partial alpha plus 2I over partial I over partial alpha. This will be result, because R is function of alpha beta plus iota I is also a function of alpha and beta. Okay, and you may say that the partial FC or partial alpha, that will be 2 will be cancel out both. This will be R partial R over partial alpha plus I partial I over partial alpha divided by R square plus I square 1 by 2. Okay, because R is function alpha beta, I is alpha beta, both are symmetric in alpha beta. So for second partial FC, 1 minute. Okay, that will be beta, that will be R partial R over partial beta plus I partial I over partial beta R square plus I square 1 by 2. Okay. Okay. Now we have to add by taking the square. So what will be the, so FC over partial alpha square plus partial FC over partial, and that is magnitude beta square. Yes, we have to take the square. Okay, alpha square beta square. Okay, so this will be equal to, we have to take the square, a square b square plus 2ab, a square plus b square plus 2ab. No, square of whole, not second order. Degree, second degree. Power, it is power, not order. Yes, वही कह रहा हूँ. Yes, that will be, that's, I will use this formula. Yes. Okay, so this will be equal to R square partial R over partial alpha square A square plus No, 1 minute. I plus partial I over partial beta whole square. 1 minute. 1 minute. Beta. Okay. Here was alpha plus, yes, you are right, I plus I over partial beta whole square. Okay. Plus 2 Ri. This will be multiply. Okay. Plus okay, whole is divided by r square plus I square. This will be eliminated. Okay, this will be equal to this. Okay. Okay. This was the result, and because that was zero term. Okay, and since Fc is analytic, so that will be satisfied the Cauchy-Riemannian condition. That is Cauchy-Riemannian equation. So if I put here, I may put I over this r over beta, that will be equal to minus I over alpha. Okay, and minus square is plus. Okay, so you will have r square partial r over partial alpha square. Yes, and partial r over partial beta is equal to plus, yes, r square partial I over partial alpha square. Okay, plus, yes, I square partial I over alpha square plus I over beta. I over beta equal to partial r over alpha. I square partial r over alpha. Okay. Yes, divided by r plus I square. Okay, so that is the result. Okay. We take r as a common. Okay, r square as common, and I square in r square partial r over partial alpha square plus partial I over partial alpha square plus, if I take I common, partial r over partial alpha. May arrange partial I over partial alpha square. Okay. Both are the same. They may take a common. Okay. So that will be r square plus I square this will be cancelled with this. Okay, so when we add these two terms, when we added these two terms, we get this result and multiply by 2, and when we put the value of this term become a 0. So you get this result, okay, and by putting the values here, you will get this result, and we taken the common. And what is this? This will be equal to this, and the derivative of with respect to C alpha and beta, what is that? That is Fc square. Yes. And what is this? We know that this is Fc magnitude of square. Why this equal to this? Now the question is that why this equal to this? Fc is equal to, Fc derivative is equal to, I have already, partial r over partial alpha plus iota partial I over partial alpha. That was derivative, sorry. And what is the magnitude? We have already explained. That will be the magnitude of Fc. Okay. By putting this value, this will be equal to magnitude of Fc square, and this was equal to this. So because this term comes from this, so that means you get a required result, that is Fc magnitude square is equal to not that was our required. Okay, got it? Okay, hello. So what was our exercise? That is exercise is del square r magnitude power n is n into n minus 1 r power n minus 2, okay, magnitude power n minus 2 Fc derivative, that is square. We have to prove it. Okay. Solution. What is the del? Del square is this is del. Okay, because complex number is 2 dimensions. So when we apply n first derivative, when we because r is function of actually function of alpha and beta, both are two variables. Okay, so that will be equal to n n minus 1 partial r over partial alpha. Okay, n into Rn minus. Okay, when we apply a second derivative, first function as it, derivative apply on a second, okay, plus this will remain the same, and derivative we apply on this, that will be n into n minus 1 r power n minus 2 because it is shifted, derivative on this r over alpha, and this will be as it. Okay, yes, this will be as it, and whenever we apply a derivative, this will be a derivative term. Okay, that's similarly you may write that is r n minus 1 partial square r over alpha square plus n into n minus 1 r n minus 2. This will be whole square. Okay, and similarly beta square this will be equal to this. Okay, if I say that this is equation x, this is equation y, this is a from a and x plus y. Okay, what you will get, del square r n, yes, that will be equal to n into r n minus 1 n minus 1 yes, this term will be added. I have taken the common r alpha square and r beta square. Okay, plus yes n into n minus 1 r n minus 2, yes, and what will be inside, this will be equal to this. Okay. Since Fc R plus iota I is analytic, therefore it will satisfy condition and Laplace equation. Okay. So partial. What is the Laplace equation? That will be a 0. So this term become a 0. Sorry. This term will come a 0. Okay, and so what will be the required result? And this become a 0. Then del square Rn, yes, that will be equal to n into n minus 1 R n minus 2 yes, this will be equal to this, but from Cauchy, because this is not making a derivative, magnitude of derivative, Cauchy Riemann equations, yeah, conditions, okay, partial R over partial alpha will be equal to partial I over beta. We may put it here, alpha or beta, it doesn't make any problem. So del square will become n minus 1 or n minus 2 1 minute. Not beta. And what is this? This is yes. If you use the second condition, that is due to minus, that will become a plus, and the alpha that will be the same. Okay. So if you do, it is up to you. If you are if you do with respect to alpha, then it is true. If you do it with respect to beta, then that is true. Okay. So this will be n into n minus 1 or n minus 2 Fc derivative. That will be a required result. Okay. So got it?